Hi, today we are going to be looking at some very specific types of algebraic expressions. Now, we've been using algebraic expressions in our previous lessons without sort of really talking about what they mean. So let's discuss some terminology here. When you create an algebraic expression, you're going to have some kind of variable, right? And a variable is just going to be some kind of letter like X or Y or Z. And this just represents basically a number from a set of numbers that you can put in place of this variable, right? So for example, you might say that you'll have some number in place of X, and X is going to be some kind of integer, right? An element of the set of integers. That's a very common way to do it. Or maybe you'll say that Y is going to be a real number, right? That's also very common for us. All right, so that's the idea with the variables. So you're going to then want to combine them to create actual algebraic expressions. It's going to be a combination of variables with numbers and operations, right? So for example, we might have something like 3x squared plus 5x minus 1. So I'm combining numbers with variables and then operations, right? Adding different terms together. That's an algebraic expression. We could also have another one. How about the square root of y cubed minus 7 divided by 2x, okay, whatever you want, another algebraic expression here. Clearly, we're going to have variables. Clearly here, there are numbers, and there are operations that are combining all of these things together. So these are all algebraic expressions, but we are going to be talking about only a specific type of algebraic expression today called polynomials. So let's start looking at what those mean. So first, what we want to do is we want to consider the number of terms that we have in our polynomial. So we're going to start out with what we call a monomial. And in mono here, mono sort of means like one. And this idea of a nomial, that has the idea of a term. Okay, so this is going to be a type of polynomial with only one term. Let me show you sort of an example here. An example might be 3x squared. Okay, so this is just by itself, that's just one term. You might have another one. How about minus 4x? Okay, that by itself is just one term. You could even have something like the square root of 2 times x to the 7th power. Again, all of this is only one term. And you could also have something like, I don't know, 101. Okay, this by itself is also only one term. Okay, so these are all examples of monomials. Let me give you the rule here. So the rule here looks a little intimidating, but really the idea is a monomial is going to have a form of this, ax to the k power, okay, where this number a in the beginning here, that is a real number, okay? So all of these sort of are real numbers, and then this x to the k, this k is going to be, well, it's going to be some integer greater than or equal to 0, so some non-negative integer. And so right here, of course, this is 2, that's a positive integer. Here we have a 1, that's a positive integer. Here we have 7, that's a positive integer. And here, well, here we actually have x to the power of 0. And so here this 0 is greater than or equal to 0. Okay, so basically a non-negative integer for the power. That's how we're going to be looking at these kinds of algebraic expressions today. So monomials are sort of the building block, right? Because they only contain one term. A monomial then, you might be able to guess, a binomial then, you'll probably be able to guess, is going to contain 2 terms. Essentially, it's going to be the sum of 2 monomials. And so one example here might be 3x squared minus 4x, right? This right here has 2 terms that are added together, right? You have a plus negative 4x. Or we could have here the square root of 2x to the 7th plus 101. Once again, this is a binomial. You have 2 monomials added together. Okay, so 2 terms in this binomial. And then, of course, a trinomial. No surprise, that's going to be the sum of 3 monomials. Okay, so you could have something like 3x squared minus 4x plus the square root of 2x to the 7th. This would be a trinomial. It has 3 terms. Okay, so that's one way we can classify these kinds of polynomials in terms of how many terms do they have. Now let's look if we have more than this. What do we do? Polynomial here is what we use to describe all of those things we just looked at. So monomials, binomials, trinomials are all examples of the general class of algebraic expression known as a polynomial, where poly means many, and so many terms, many nomials, right? So let me show you the general form here. In general, you can have any number of terms, and as they get bigger and bigger, it sort of makes sense to write them down in this way, where you have essentially an index for this constant, for this number, raised to some power here of n, and typically you're going to list them from the biggest power down smaller until you get x to the 1, and this is x to the 0. So you go from biggest power to smallest power. And if you do that, then this, you say, would be written in standard form. Okay, standard form takes a polynomial, goes from the biggest power to the smallest power, which would be x to the 0 here. Okay, now you don't have to write a polynomial in standard form. If you were to write a polynomial, for example, like 4x plus 3x squared minus 1, well, it's kind of not from biggest power to smallest, so this is just not standard form. That's all that's going on here. This is not standard form. Okay, let's take a look at a large polynomial, for example, here. Let's look at, what if we have 4x to the 5th power minus 3x to the 4th power plus 2x to the 3rd power plus 100x squared, whatever you want, plus 99x minus 2. Okay, so here we go. This is going to be a polynomial. Now notice it has 1, 2, 3, 4, 5, 6 terms. Okay, it has 6 terms here, and we're starting from the highest power and incrementing down with each term. And so this is going to be in standard form. Okay, so here we have a polynomial with 6 terms. Now, what if I was to take this polynomial and delete some terms, right? What if I delete this one, and let's delete this one, and let's delete this one? Okay, so now I've got a polynomial with 3 terms, and so we can call this a trinomial, okay, just because it has only 3 terms. So that's the idea with a polynomial. Now we can also describe polynomials another way, not just in terms of how many terms they have, but by their degree. What does this mean? Well, when we look at the degree of a polynomial, what we're really looking at is the highest power of the variable. Okay, so let's look at an example here. What if I have x cubed, x to the 4th minus 3x plus 1? So in this case, we're going to see that I have a 4 here. That's the biggest power. So I'm going to say this is a polynomial of degree 4. All right, that's what I have here. What if I have another one? How about x squared minus 3x cubed plus 2x? Okay, so here I have another polynomial, and the highest power here is going to be this 3. So this is going to be a polynomial of degree 3. Okay, that's all we're looking for. What's the highest power you have in your polynomial? That's the degree. And if it's written in standard form like this, then that will be the first term, right? The biggest power there would be in the first term. All right, so let's take a look here and see if we can sort of sort this out a little bit. So I could have something with degree 0, 1, 2, 3, 4, or higher, right? So let's look at an example here. A polynomial of degree 0, well, that would be something like the number 3, just by itself. And so this we can call just a constant. Okay, a constant is just a number. It never changes. There's no variable to change. Okay, so that's pretty easy. Now, if I have a polynomial of degree 1, that means I'm going to have something like 2x to the first power. Okay, if it's the first power here, I can leave that away. And so something like this is going to be essentially what we call a linear expression. And later on when we learn to graph these, you're going to see that a polynomial with degree 1 is going to be graphed as a straight line. So this is a linear relationship, a linear polynomial. If you have a polynomial of degree 2, well, this is going to be something like x squared plus 3x, okay? And something like this, we are actually going to call this a quadratic polynomial. Now, normally you might think quad means 4, so it's kind of weird that we're using that to describe essentially a polynomial that's squared in its highest degree. But that is because in Latin, squared is written as quadratus, okay? And that's because quadratus is this quad is referring to the 4 sides of a square. So a square is 4 sides, so squared is quadratus, and so we use quadratic to describe a squared polynomial, okay? It's a little bit confusing, but that's just what we do, okay? That's the habit here. Now, if you have a polynomial of degree 3, well, that's going to be something then like, I don't know, 4x cubed plus 1. Okay, here's a degree 3 polynomial, and we can call this a cubic polynomial because the highest term here is cubed, right? So that one actually does make sense. And finally, let's get to a degree 4 polynomial. So, this might be something like minus, let me do this in blue, minus 5x to the 4th power minus 3x, whatever you want. You can have other terms, but as long as the highest term here is of degree 4, this we will actually call a quartic polynomial. Okay, so you sort of get that quartic. It's a little confusing. After this, degree 5 would be like quintic, so you can go higher, but typically for us, we're going to stay typically under 4. So we'll go up to cubic in most of our discussions, and we'll focus a lot on quadratic polynomials and quadratic expressions. That's going to be a big chunk of our time in this course. So what I want to show you is that when we're talking about polynomials, there's essentially 2 things that we can use to name them, right? The first one here would be the number of terms. So we can call this like the type, right? And the type would be based on the number of terms. So this would be a monomial, binomial, trinomial, a quadrinomial, or just a polynomial with 5 terms or with 6 terms. The next thing we can look at is not just the number of terms, but the degree, okay? And so for this, you want to look at the highest power that's present in that polynomial. And so that would just be a degree 2 or a degree 3, or you could say a quadratic polynomial or a cubic polynomial or a constant or a linear, whatever you want like that. Okay, so 2 ways to describe polynomials. Let's do a little bit of practice with these naming. So here I've got just a list of 6 different polynomials, and I want you to try and think about what are the different types and what are the different degrees for each of these polynomials. So why don't you pause the video here, give it a shot yourself, and then come back. We'll fill out this table together. All right, so let's fill this out. So for this first one, we have 3 terms, so this is going to be a trinomial. And the highest degree here is going to be this 2, so we'll just say this is a degree 2 polynomial or a quadratic polynomial. This next one looks like it only has 2 terms, and so this must be a binomial. And it will be of degree 7. Okay, that's the highest power that we have here. Next, the number 17. Well, that's just 1 term, so this is going to be a monomial. And since the highest power here is, well, this is essentially x to the 0, right? So this is going to be of degree 0 or a constant polynomial. The next one here, we see we're going to have 4 terms, and so you can call this just a polynomial with 4 terms, or if you wanted to, you could call this a quadrinomial. You could just say 4 terms, and the highest degree is that 5, right? So this is going to be a degree 5 polynomial. The next one here looks like 2 terms, and so this is going to be a binomial. And the highest power here is a 3, so that'll be degree 3. And the last one looks like this will also be only 1 term, a monomial, and the highest power is going to be 2. So this is a degree 2 polynomial here for the last one. All right, so hopefully this gave you a good look at the idea of this specific type of algebraic expression known as a polynomial. There are other types we can construct, but for polynomials, we can look at either how many terms they have, right? Monomial, binomial, trinomial, or the highest power in that polynomial, and that's going to be its degree. All right, so come back next time, and we're going to learn how to add and subtract polynomials. I'll see you there.